Hello everyone, today we are gonna solve construct binary tree from preorder and inorder traversal. So in this problem, we are given a preorder and inorder arrays which contains the values. And what we have to do is using this preorder and inorder traversal of a binary tree, we have to build a binary tree and then we have to return this root of a binary tree. So first of all understand what is this inorder and preorder. I have detailed explained this earlier videos. You can refer that videos. But in short, I can say what is my inorder. In inorder, my traversal is look like first I traverse left subtree, then I traverse my root, and then I traverse my right subtree. And in preorder, first I traverse root, then I traverse my left subtree, and then I traverse my right subtree. So here, what how I am gonna solve this? If you see what is this 3? What is this 3? So in preorder, my root is, I can simply say in preorder, my root is preorder 0. This is my root. This will be my root. So what I am gonna do is I will create one root, this. And now after creating this root, I have to find what should be in its left and what should be in its right. So how do I find that? For that, I will use this inorder array. So if you see in inorder array, if I find where this 3 is, so this 3 is here. This 3 is here. So what I can conclude from here? So if I write it here, 9, 3, 15, 27. This is my inorder. So, and here is my root. Here is my root. So as I have said earlier, this is my inorder traversal. So before inorder, before this root, I have my left subtree, and after root, this is my right subtree. So I can say this is my part of right subtree and this is my part of left subtree. Okay, so I can say if I have created this root, so my left subtree would look like this and right subtree would look like 15, 20 and 7. I don't know how it will look like, but I am sure that in left subtree I have only 9 and in right subtree I will have this. But now after knowing this, what will be, if you see clearly here my have in order this and my preorder is this. But here what I can say, this is my inorder, and in right side this is my inorder. So you can say our inorder from this reduced to this. So we can say our problem is reduced to sorted input. Yes, reduced to sorted input. Now can I guess what will be my preorder for this and what will be my preorder for this? Let's see how we can find that. So in preorder, what is my preorder is? Preorder is 3, 9, 20, 15, 7. So after root I have left. First of all, after root, so this is my root right now. So after that I have left. So first of all I will have left and then I will have right. So at which point I have left subtree? How do I find? So I will find that from here. So if my root is here, then I can say this number of element. Let's say this number of element is x. Then from here x element are part of my left subtree. So here x is 1. So I can say this is my preorder, and here my preorder will be after x element. From here, if I am here, then after x element to the end, this will be my right. This will be my right. So what I can say, my preorder is 20, 15 and 7. This is my preorder for this. So what I am doing is, if I write it in a point, first of all I find the root from preorder, finding root from preorder, and then find that root, find that index in inorder, find I root in inorder, And after finding this in root, I will say from I start, let's say this is my I start is this, from this to I root minus 1, this is my I root minus 1, this will be my left subtree, and from I root plus 1 to I root plus 1 to I end. Where is I end? I end it will be there. To I end, this will be my right, and this left and right is for in order. And same thing we have to do for preorder as well. So how do I find preorder? What will be my preorder? So my preorder will look like, if I say this is my P start, so what I will say to finding P, this will be very easy. From this from P start plus 1, from P start plus 1 to P start plus X. And what is this X? This X is this. You can say, what is this X is? This X is basically, what is this X? This is I root. This is I root minus I start. This is I root minus I start. And what I have to do finally is, I have done this left, and this is my left. And what is my right? What will my right? Right is from this P start plus X. P start plus X is the end point. I have to do plus 1. So this is P start plus X. So P start X plus 1 will be there. From here to P end. And what will be P end? P end will be this. So this will be my preorder for right. So now till now what I have done, I have my preorder and I have my inorder. I have find this root in this inorder, and I will say the left part of this root will be my left subtree, and right part of this will be my right subtree. After finding left subtree and right subtree, I find this. I can say I find in order of left subtree and right order of right subtree. So I have find in order. Now what I have to do? I have to find the preorder also. So how do I find the preorder? So if this is X, so from here my X number of element will be my left subtree preorder, and from after X the rest will be my right subtree. So I hope I am clear till now. So now let's understand how we will solve it further. Now what we will do here, we will reiterate, what our problem. So now if you see, this is my smaller problem. So what I will do, first of all, from preorder, this will be my root, for this root I will find this root in my inorder. So here it is. So before this will be my left, and after this will be my right. But here before this there is nothing, after this also there is nothing. That means it is null. Its left and right child is null. So what I can say that I have only single node here. So this will return. So when it return, I will make this link. I will make this root left to this. Now what I have to do, I have to solve this. So from here, this preorder 0 element, this is my, what is this? This will be my root. So for this root, first of all I find here. So I find it here. Now I will say this will be my left subtree, this will be my right subtree. So what I will do, I will make this root, and I will, for this root, let's remove this. I will remove this and make this root here. So I have this 20 root, and for this root I will have my 15, and here also my 15. This is my inorder, this is my preorder, and this is my, there is no link right now, and there is 7, and for 7 also there is 7. So if you see, I find there will be no left and right, and there is no left and right. So this will be our node, and this will return to its left. So our left will point to this. This will return to its right. So our right will point to this. Okay. So once our this is done, so it will returns to its right. So it returns to its right. So now right will point to this. So this is how we will solve. So I hope you understand the intuition. So now let's check out the code. And so now what we are doing is we are first of all, for finding this in order, finding the root in order, we will use this hash map so that we can find it in O1. Otherwise, if we find it our root in order, it will take O n time. So to reduce its time complexity, we will store our in order in our hash map. So what we are doing is, first of all, we create an in order map, and in order map we are creating we are storing this index. So what I am doing for 9 I will store its index is 0. So this 3, this index is 1. So this is how I am storing its index, so that I can do search in O1 time. After doing that, what we will do, I will create one function. For that I am passing my preorder vector, my p start, my p end, and my map. I do not need this in order vector now, because I have used this map. So I will use this map and sending this I start and this in order this. So you can think like this. So here what I am doing is I initialize my I start here, and initializing my I end here, and initializing my p start here, and initializing my p end here. So this is my how right now looks like. So what I am doing is, if my p start cross this p end, or if my I start cross this I end, I will return null. That means there is no element left in our array. Otherwise, what we will do, first of all, I will create root. Which root I have to create? I have to create this p start one root. So I will create this root. Once I create this root, I have to find that root in my vector. So how do I create? With the help of map, I can search it O1. If I will not use this map, I have to do it in O of n while using one for loop. But for we already know how to use this, so we will use map. So now after doing this, what we have to do is we find our root. Let's say this is my I root. This is my I root. So once I find I root, now I have to find that x that I told earlier, that this will be our num's left element. So this will be my I root minus I start will be the number of element in left subtree. And once I find my left subtree, then I can build I can call for my left and for right. How do I call for my left? For left, I will say this preorder, then p start plus 1. So for left, what will be my p start from here? It will start from 9 and till p start plus nums plus left. So it will end till left. So you can say this 9 is my left preorder, left subtree preorder. And for in order, I will start from I start till I root minus 1. This is my I root, so this is my in order. In order is only 9. And how do I, and what will be written from this? It will be, so from here I will return this 9. So when this 9 is written, I will make my roots left to this 9. So this is how I am pointing. Root left will point to what value is written from left. And similarly, how's my right will be starting from p start plus 1 plus nums left. That if after 9, this will be my new preorder, and it from till end. And for in order, I will start from I root plus 1, this 50 to I end. So this is how I will solve. Finally, what will return this 20? I will make this my root right, and after that I will return this root. I hope this whole intuition and the source code is clear to you. Now let's understand what will the time complexity. So the time complexity of this will be O of n, and the space complexity of this will also O of n for using this hash map. Plus O of n for this functional call stack. But we can say O of n plus O of n will be O n. So our space complexity is also on. I hope you understand everything. If it helps you, do not forget to hit the like and subscribe button. Thanks for watching.